Today we're going to show you that any object moving in constant motion has zero net force on it. And I'm going to use Tracker and Python to show that this is true. Here I have an exercise ball that I had my mother help me push. And after it's pushed, there's a constant motion and there's no force acting on it. And you can see to the right here that as the time and position increases, then force is kind of staying the same. That's shown by this straight line linear graph right here. And if we go to Python, we have it set up here, and I got the ball mass. I took the ball's mass, and it was about 3 pounds, so that's about 1,300 grams, a little bit more, as you can see. I started the ball at the origin, and so the position is 0 initially. The ball velocity I calculated at 1.76 meters per second, and I stopped it at 0.766 seconds. And here are the equations for the ball velocity and position. You can see ball velocity plus F net over ball mass times delta T, ball position plus ball velocity times delta T. And I'm going to go ahead and run this. And as you can see, the ball moves to the right, positive x direction, just as the ball does in the tracker model. And the line is linear, just as you see in the tracker model, a little bit straighter because it's more precise, because my clicks aren't exactly perfect. So we're going to go to Excel and compare the graphs. Scroll up here. Here is a tracker graph. As you can see, it's not completely straight like the Python graph, but when you put them together, you can see that they're pretty much the same. The tracker model graph does not veer too much from the Python graph, but as you can see kind of in the beginning, it's pretty much on the same line throughout. And so I mentioned earlier that I had put the ball, I'd started the origin where the ball began, and I did this because I thought it would just be easier to put the ball at the origin and move it to the positive x direction. If I had decided to put the ball, the origin where the ball had ended, I would just have negative x values. Actually, it would start at negative x values and slowly increase. The graph would probably be the same, but it just have negative x values slowly decreasing till 0. And pretty much after the ball is pushed, there are really no forces acting on it. Friction is kind of low since the ball is so big, its mass is so big. The friction is kind of not really applicable here, but you could argue that friction here is present because it is, but it's really small, so it doesn't have too much effect on the ball. That's really the only force that would be applied or acting on the ball during its constant motion, that and possibly air resistance, but those two are really not applicable in this case. So pretty much there are no forces really acting on the ball after its initial push. Thank you for listening, and I hope you learned something today about constant motion and forces. Thank you.